70 million Americans are under heat alerts, and across parts of the country, this isn't just another hot summer afternoon. It's a heat wave that is refusing to let go. Temperatures are climbing into the triple digits in parts of the South, while humidity is making conditions feel even hotter. Recent reporting has put more than 70 million people under heat alerts, with some areas facing heat index values around 105 to 115 degrees Fahrenheit. But here's what makes this situation especially concerning. The heat doesn't simply disappear when the sun goes down. In some locations, nighttime temperatures are staying unusually high, giving people far less opportunity to recover before another dangerous afternoon arrives. And that creates the real question: how long can this pattern continue? Because this story isn't just about how hot America gets. It's about what happens when the heat stays. Look across the southern United States right now and the signs are everywhere. Bright sunlight beating down on roads, cities glowing beneath layers of warm, humid air, air conditioners running for hours, people looking for shade wherever they can find it, and weather maps covering enormous sections of the country with heat alerts. The number alone is difficult to visualize. 70 million people. That's not one city, is not one state. It's an enormous population spread across multiple regions, experiencing dangerous heat at the same time. And the problem isn't simply that afternoon temperatures are high. Duration matters, humidity matters, and perhaps most importantly, nighttime temperatures matter. A single extremely hot afternoon can be difficult, but when the temperature remains elevated through the evening, through the night, and into the next morning, the body gets less opportunity to cool down. That's when a heat wave can become something very different. It becomes an endurance test. And according to current reporting, that's exactly what parts of the South are dealing with this week, with extreme heat and humidity expected to persist. But why is the night so important? To understand that, we have to stop looking at the thermometer for a moment and look at the clock. Imagine the hottest part of the day. The sun is directly overhead. Roads shimmer. Buildings absorb heat. Air conditioners work constantly. The temperature climbs toward its daily peak. Eventually, the sun begins to set. Normally, that's when release begins. The sunlight disappears. The ground gradually loses some of the heat it absorbed. Temperatures begin falling, and your body finally gets a chance to recover. But during a prolonged heat event, that recovery can be limited. The temperature might fall only slightly. The humidity can remain high. Buildings and pavement can continue releasing stored heat, and the air itself can remain oppressive long after sunset. In some urban areas, overnight temperatures can remain around 80 degrees Fahrenheit during severe heat events. That might sound much better than 100 degrees. But think about what happens next. You go through one extremely hot day, then you get a night that isn't cool enough. Then the next morning begins. Instead of starting from a comfortable baseline, you're already dealing with residual heat and another forecast of extreme temperatures. Day 1 becomes day 2. Day 2 becomes day 3. And suddenly, the heat wave isn't just attacking the afternoon, it's occupying the entire day-night cycle. That's when the duration becomes so important. And it raises another question. Why isn't the atmosphere simply breaking this pattern? Why does the heat keep rebuilding? One explanation often used for prolonged heat events is a persistent area of high pressure. You've probably heard the term heat dome, but don't picture a giant invisible bubble sitting over the country. That's not really what's happening. Instead, think about the atmosphere as a constantly moving system. When a strong area of high pressure becomes established, air tends to sink. As that air sinks, it warms. Cloud development can be suppressed, sunshine can become more persistent, and the resulting conditions can help maintain high temperatures near the surface. If the pattern remains in place, the heat can continue day after day. That's why meteorologists aren't only asking how hot tomorrow will be. They're asking what the larger atmospheric pattern will do afterward. Will the high pressure weaken? Will it move? Will another weather system push into the region? Will clouds and storms increase? Will winds change? Or will the same basic pattern remain locked in place? Those questions determine whether a heat wave is about to fade or continue. And right now, the forecast is still pointing toward persistent heat across parts of the South and Southeast. NOAA's Climate Prediction Center has highlighted elevated chances of above normal temperatures and extreme heat across parts of the region. But there's another detail that makes the story bigger. The map. At first, imagine a weather map showing one small region under a heat alert. Then another area appears. Then another. Soon, the highlighted region stretches across multiple states. And suddenly, the statistic makes sense. When meteorologists say tens of millions of people are under heat alerts, they're not saying every one of those people is experiencing exactly the same temperature. They are describing a massive area where different levels of heat-related risk exist. Some places may be dealing with extreme temperatures. Others may be facing dangerous combinations of heat and humidity. And some locations may experience the worst conditions during the afternoon, while others struggle more because of oppressive overnight temperatures. The map tells you the scale, but it doesn't tell you everything, because two places can have the same thermometer reading and still create very different levels of heat stress. That's where humidity enters the story. Your body has a built-in cooling system. One of the most important parts is sweating. As sweat evaporates from your skin, it helps remove heat from your body. But evaporation doesn't work as efficiently when the surrounding air is already full of moisture. That's why a hot and humid day can feel dramatically worse than a dry day at the same temperature. This is also why meteorologists use measures such as the heat index. The heat index combines air temperature and humidity to estimate how hot conditions feel to the human body. And during this heat wave, some locations are seeing heat index values well above 100 degrees, with forecasts reaching around 115 degrees in parts of the south. That's an important distinction. The thermometer might say one thing, your body may effectively experience something much more stressful. And this is why heat isn't simply a number on a weather app. It's an interaction between temperature, humidity, duration, sunlight, activity, and the ability of the body to cool itself. Which brings us to the people who face the greatest challenges during prolonged extreme heat. Not everyone experiences extreme heat in the same way. Older adults can face greater risk. Young children can be more vulnerable. People working outdoors may spend hours exposed to the heat. Athletes can generate additional body heat through physical activity. People without reliable access to air conditioning can have fewer opportunities to cool down. And people with certain health conditions may be especially vulnerable. But there's another misconception worth clearing up. Extreme heat isn't only dangerous for people who already have health problems. A healthy person can also become overheated when temperatures and humidity remain extreme for long enough. That's why heat alerts aren't simply telling people that the weather is uncomfortable. They're telling communities that the conditions can become hazardous, and the longer the event lasts, the more important those warnings become. Because the impact doesn't stop with the human body, it begins spreading through the systems around us. Think about electricity. When temperatures soar, air conditioning demand increases. Millions of people are trying to cool their homes, offices, schools, stores, and other buildings at the same time. That puts additional pressure on the power system. Then, think about transportation. Extreme heat can create challenges for roads, rail systems, vehicles, and outdoor operations. Think about water. Hot weather can increase demand for water as people and communities try to stay cool. Think about agriculture. Crops and livestock can experience additional stress when high temperatures persist. And think about ordinary daily life. Outdoor work becomes harder. Sports schedules can change. Schools may modify outdoor activities. People alter when they travel, exercise, shop, or work. But the longer the heat continues, the more adjustments become necessary. That's why a heat wave isn't simply a temperature event. It's a system-wide event. And the longer it stays, the more pressure builds. So what does "it's about to get worse" actually mean? It doesn't necessarily mean every location will suddenly become 10 or 20 degrees hotter. That's not how weather works. Worse can mean several different things. A higher afternoon temperature, a higher heat index, more locations reaching dangerous thresholds, a longer period of extreme conditions, or nighttime temperatures refusing to fall enough. And that last one may be the most important. Because imagine two different heat waves. In the first one, the afternoon reaches 105 degrees. But overnight, the temperature falls significantly. People finally get several hours of cooler conditions. In the second scenario, the afternoon is similarly hot, but the night remains unusually warm. Then, the next day brings another extreme afternoon, and another warm night. The difference is enormous. The body gets less time to recover. Homes and buildings may remain warm. People who work outdoors face another day of exposure. And the cumulative effect becomes more important. That's why meteorologists aren't watching only the afternoon maximum. They're watching the minimum too. Think of the heat wave as a cycle. Day 1, extreme heat. Night 1, limited relief. Day 2, extreme heat returns. Night 2, still unusually warm. Day 3, the cycle repeats. That's when the heat begins to feel less like a single weather event and more like a persistent atmospheric condition. The heat isn't just arriving, it's staying. And eventually, something has to break the pattern. A weather system can move in, the jet stream can shift, winds can change, clouds and storms can increase, a cold front can push into the region, or the high-pressure pattern itself can weaken or move away. But there's an important catch. The heat wave doesn't necessarily end everywhere at the same time. One city can begin cooling down while another remains under extreme heat. One region can receive storms while another stays sunny. One state can see temperatures fall while another continues facing dangerous heat. So when someone asks, when will the heat wave end? The real answer may depend on where you are. And that's why the forecast map can change dramatically from one day to the next. But there's a much bigger question hiding behind all of this. Why are extreme heat events such an important climate story? The answer requires some careful distinction. Weather is what is happening now, Climate is the longer-term pattern. Scientists have found that human-caused climate change has increased the likelihood and intensity of extreme heat in many parts of the world. But that doesn't mean climate change alone explains every individual heat wave. Every event has its own atmospheric setup, the position of high pressure, the jet stream, soil moisture, humidity, wind patterns, ocean conditions, and many other factors. Scientists can study those ingredients individually and then determine how much a changing climate influenced the probability or intensity of a particular event. That's very different from simply saying, climate change caused this exact heat wave. The immediate story is the weather pattern happening right now. The bigger story is that the background climate is changing the conditions under which extreme heat occurs. And that's why this heat wave matters beyond this week. Now, bring the camera back down to the ground. Forget the atmospheric charts for a moment. Think about a person walking outside in the afternoon. The air is heavy, the pavement is hot, the sun is intense. Then imagine doing the same thing tomorrow, and again the day after. That's the part of a heat wave that statistics don't fully capture. The number of people under alerts tells us the scale, the temperature tells us the intensity, the heat index tells us how temperature and humidity interact. But duration tells us how long people have to deal with it. And that's the variable that can turn an uncomfortable period into a prolonged hazard. So what happens next? The immediate sequence is relatively simple. The current heat continues. Some locations reach their peak. Others may see the worst conditions later. Nighttime temperatures remain important. Then the atmospheric pattern begins to change. Eventually cooler air moves into some areas, but not necessarily everywhere once. The weather map changes. Alerts inspire. And temperatures begin falling. The question is, how long does that take? Because 70 million people isn't really a number. Behind that number are neighborhoods, cities, highways, homes, factories, schools, workplaces, outdoor job sites, sports fields, and millions of individual decisions about how to deal with the heat. That's why extreme heat can be so deceptive. There may be no dramatic wall of clouds, no giant storm crossing the horizon, no roaring winds. Sometimes the sky looks almost completely ordinary. And that's exactly what makes extreme heat different. The danger can be quiet. If it can build gradually, it can become more serious simply because it refuses to leave. And that brings us back to the question we started with, how hot can it get? The answer matters, but it isn't the only question. How humid will it be? How many days will the heat continue? How warm will the nights remain? How large will the alert area become? And when will the atmospheric pattern finally break? Those are the questions meteorologists are watching now, because the temperature tells us what is happening. The duration tells us how long we have to deal with it. The heat will eventually weaken. The high pressure pattern will eventually change. The alerts will eventually expire. The temperatures will eventually come down. But until that happens, millions of people will continue waking up to another hot morning, another dangerous afternoon, and another night when the air may not cool as much as they want. And that is the real story behind this heat wave. Not simply that America is hot, not simply that some cities are reaching triple-digit temperatures, and not simply that more than 70 million people are under heat alerts. It's that the atmosphere has created a pattern capable of keeping the heat in place for days. And when the heat refuses to leave, every additional day matters, every additional hot night matters, every additional hour outdoors matters, and every shift in the forecast becomes something worth watching. So the next time you look at a weather map and see a huge red area stretching across the country, don't just ask, how hot is it? Ask another question. How long is it going to stay this way? Because sometimes the most dangerous weather isn't the weather that arrives with the biggest headline. It's the weather that simply refuses to leave. And for millions of Americans under the current heat alerts, that's the part of the story meteorologists will be watching most closely. Not just how hot America gets, but how long it stays that way.